Explain how we can determine if a triangle is right-angled if we know the length of each side. Basically, if the square of the hypotenuse is the same as the sum of the squares of the other two sides, this will be a right triangle. So let's just say we've been given a triangle right here. For example, 8, 6, and 10. Okay, and we wanted to figure out whether or not a triangle is right-angled. Well, what we're going to do is we're going to take the sum of the two smaller sides, so 8 squared plus 6 squared, and in that case it's going to be 64 plus 36, which is equal to a 100. Now on the long side, or the hypotenuse, that's 10. If we take the square of that, that's 100. You notice that the answers here are identical. When they are identical, we have a right-angled triangle. In B, L is the point O and 1, M is -3 and 3, and N is -7 and 0. I've drawn this right here so that you can see this. We have to prove that this triangle is right-angled. So what we're going to do is find the distance for each one of these sides. Okay, so we're going to find first the distance between L and M. Okay, so we're going to use the distance formula. First off, you're going to work with your x's, and then you're going to work with your y's. So with L and M, we're going to have -3 minus 0 squared. Okay, those are the x's for both of those. Plus, we're going to work with the y's of both of those, and those are going to be squared as well. The y's are going to be -3 minus 1. Okay, so condensing this one a little bit, what we're going to have is we're going to have -3 squared plus -4 squared. This is going to turn out to be 9 plus 16, which is going to be the square root of 25. So the distance between these 2 points is just 5. So next up, we're going to start with the distance between M and N. Alright, so placing these into the distance formula, M and N, well, you're going to start with your x's first and then your y's. Your x's is going to be -7 minus a -3 squared, and you're going to have 0 minus a -3 squared. Those are the y's for M and N. Okay, condensing this down, you're going to have, well, -7 minus a -3, that's going to be -4 squared, plus a +3 squared. So 0 minus a -3 is going to be +3. Working this one out, you're going to have 16 plus 9, which condenses down to 25, the square root of 25, which is just going to be 5, just like the last one. So you had D, the distance between M and N, is going to be 5. We're going to find the distance for the last side, so that is between L and N. Alright, so plug all of these into the distance formula. What you're going to have is -7 minus 0 for your x's squared, plus 0 minus 1 squared for your y's. This condenses down to -7 squared plus -1 squared, okay, which is basically 49 plus 1. This is the square root of 50. But before we go any further, remember what I said for example 3A. It says here, explain how we can determine if a triangle is right-angled if we know the length of each side. Now, I said that if the square of the hypotenuse is the same as the sum of the squares of the other two sides, then this is a right triangle. Well, we know that the distance here is going to be the square root of 50. I'm not going to go any further, but we do know that if we square this right here, it's just going to be 50. Now, if you take the squares of these ones, okay, so 5 squared plus 5 squared, if they do equal 50, then we have a right angle triangle. So 5 squared is going to be 25, and 5 squared here is going to be 25 as well. And you add them up together, you have 50. Exactly what we have over here. So can we say this is a right angle triangle? Absolutely.